Kia ora, Year 12. This is a video that I'm going to do to go over the cross product because I know some of you are still not enjoying it. So what we're going to look at in here is how we can find a vector that is perpendicular to two other vectors. Right, so the vectors we're going to work with are these. We're going to have 4, -1, and 3. And we're going to have 3, 5, that's 5, and -1. I might just change the pen a little bit. Okay. So what we want to do is to set up those vectors horizontally to help me with a memory jog. So the cross product goes like this. We've got 4, -1, and 3 for the 3 components of the first vector, 3, 5, and 1 for the 3 components of the second. The thing we looked at in class today was a way to remember that the middle one is a negative. So we just wrote that in there now. Now we're ready to go. So the cross product of those two things, we'll call them N1 and N2, is going to equal this. First thing we do is we get rid of that column there. That gives me -1, 5, 3, and 1. I don't know what's gone wrong with that pen. There we go. Try again. -1, 5, 3, and 1. The next one is the negative determinant. I wipe out the middle column, and I'm left with this 4, 3, 3, and 1. And the last one is back to being a +1. So I scrub out that column, and I find this determinant here. Now what? Well, I just have to work those things out. So the first one is equal to -1 minus 15. The second one is the negative of 4 minus 9. And the last one is 20 minus -3. That gives me my vector -16, -5, so that's just 5, and now 23. Now, in case you don't believe me, we're going to check that they work. So we've got 4, -1, 3, dot -16, 5, and 23. That equals -64 minus 5 plus 69, which is 0. Okay, so we've shown that they're perpendicular because if I've got a dot product of 0, that means that cos theta is equal to 0, and that happens when theta is equal to 90 degrees. Okay, that's all for now. I hope you like the sparkly pen. Let me know if this helped.